Hello everybody. Today I can identify sequences of rigid motions by checking for orientation and crossing out which does not match up. And this lesson is for multiple choice. Very commonly asked Regents question. I know I taught about orientation in the previous video, but I'm just going to do it again because this is just so important. So where am I? I am here. Orientation is seeing the same face. So if I translate, I see the same face, orientation is the same. If I rotate, I see the same face, orientation is the same. If I do a single line reflection, the orientation changes. If I do a double line reflection, it ends up where it started. So a single line reflection changes the orientation, and if I make this a tiny calculator or a giant calculator, the orientation is still the same. So they all preserve orientation except for a single line reflection. So I'm going to write that again here. It's super important. They all preserve orientation except for a single line reflection. So a rotation keeps orientation. A translation keeps orientation. A double reflection keeps orientation. Only a single reflection does not. So we're not going to even do the baby steps here. We're going to go right to number 4. To check for orientation, we talked about that in the previous video. You're looking at the order of the letters. So we have A, B, C, D, E. A, B, C, D, E. And then we have on the image A, B, C, D, E. The top one is going clockwise. The bottom one is going counterclockwise. The orientation is different. So you need to know exactly what that means when we find out that the orientation is different. The only way to get different orientation is a single line reflection. And it's very important you understand a point reflection is a rotation. I know that's confusing. So a single line reflection, it must be. So I look at the choices. Choice 1, dilation and rotation. Is that a single reflection? No, there's no reflections, so that can't be correct. Translation followed by a rotation. Are there any line reflections? No, so that can't be correct. A line reflection, boom, there it is, followed by a translation. Is there one reflection? Yes, there's one reflection, so that would change the orientation. A line reflection, followed by a line reflection. A double reflection. A double reflection is not a single reflection. A double reflection will preserve orientation because it'll put it back where it started. That's your answer. For these questions, you're going to be able to eliminate either 2 or 3 choices just by checking for orientation. And we'll talk about what happens when it only eliminates 2. From there, you'll just do the transformation and see if it works. Number 5, we're going to check for orientation. So I have A, B, C. And we follow the order of the letters that it gives us in the problem. That one is going clockwise. We've got D, E, F. That one is going clockwise. They're going in the same direction, therefore it has the same orientation. So I know that it can't be a single reflection. So choice 1, a reflection over a line. That's a single reflection. It can't be a single reflection because the orientation is the same. A point reflection through 0, 2. A point reflection is not a line reflection. So there's no line reflection here. That one will give you the same orientation. a translation followed by a reflection over the x-axis. That's a single reflection. It can't be a single reflection. A translation and a reflection over the y-axis. That's a single reflection. It can't be that one. The only one that's not a single reflection is choice 2. And let me rephrase. The only one that's not a single line reflection is choice 2. A line reflection changes, a single line reflection changes orientation. A double line reflection doesn't. Point reflection doesn't. Only a single line reflection does. This question a lot of students get wrong, but when they do it the way I do it, it's very, very easy. Check for orientation, ABC, DEC. ABC is going, that is counterclockwise. DEF is going clockwise. Orientation is different, which means the only way to get different orientation is a single line reflection. It must be a single line reflection. Which is the only choice that has a single line reflection? A single rotation, no. A single line reflection, that one looks good. A translation and a dilation, that's not a single reflection. A reflection followed by a reflection, a double reflection is not a single reflection. A double reflection will preserve orientation. Your answer is choice 2. So let's go to one now where you're not going to be able to eliminate all of them. So let's take a look at number 9. A, B, C, D, E, F. We check for orientation. A, B, C, D, E, F. A, B, C is going counterclockwise. D, E, F is going counterclockwise. The orientation is the same. If the orientation is the same, you need to know what that means at this point. You need to know that that means that it is not a single reflection. So anything that has a single, and let me rephrase, a single line reflection. So this curriculum's new, and now point reflection's a thing. I'm so used to saying a single reflection. I need to train myself to say not a single line reflection. So we're going to cross out all the choices that have a single line reflection. Choice 1 is a reflection over the x and a reflection over a y. That's a double line reflection. That one's okay. A point reflection through the origin, that doesn't count as a line reflection, followed by a reflection over the line y equals x. This is a single line reflection. It's out. Can't be that. Again, a point reflection is not a line reflection. A rotation followed by a reflection over the y-axis. This is a single reflection. It can't be a single reflection. A translation followed by a rotation. It does not have a single reflection, so that could be it. So now I'm down to 2 choices. Now that I'm down to 2 choices, we're going to have to do it. We're going to have to pick one of the choices, and we're going to have to do it. So one option is a reflection and a reflection. Another option is a translation and a rotation. Rotations are annoying. We have to turn our paper. So if we can avoid a rotation, then I want to avoid the rotation. I'm going to try choice 1. Reflection over the x followed by a reflection over the y. I'm just going to pick one point. I'm mapping ABC onto DEF. So I'm going to use point B. I'm going to reflect it over the x-axis. 1, 2, 3. 1, 2, 3. Now I'm going to reflect it over the y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Did it land on the point that it was supposed to land on? Does B correspond to E? Yes. Looks good. If I want to be sure, I could pick another point and do it. Let's pick C. reflection over the x, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, followed by a reflection over the y. Yup, C landed on F. I'm confident. I'm going for that. Again, if I can avoid the rotation, I want to avoid the rotation. I think I took those examples out, or I put them in the back. So checking for orientation, we'll get 2 or 3 choices to go away. Obviously, if it gets 3 choices to go away, I'm set. I have my answer. If it gets 2 choices to go away, then I just need to go through one of the options and see if it works. And again, if I can avoid the rotation, I'm going to do that. So I think that's all I need to do for you here. Practice it. Very, 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 very important lesson. Do the examples that are here, and that's it. Enjoy.